Good afternoon, everybody. Welcome to this webinar by Secure Ideas. My name is Jason Wood, and I'll be doing the presentation today. And just to check, I want to make sure, is everybody able to see my screen appropriately and see the slides at this point? Okay, great. Thank you very much. So, again, thank you all for joining. We appreciate you guys coming out and spending an hour of your day to sign in and listen to this presentation. We really hope that you'll find it useful. Some background information about me. My name is Jason Wood. I'm a senior security consultant for Secure Ideas. And to give you guys some background, I guess, about where I come from, I started out as a systems administrator, working primarily in web shops. So I got to live through the whole .com experience and watch all kinds of crazy things happen as my employer at the time fooled around with their numbers and whatnot. But I learned a ton through that experience and working with systems that are online, heavily trafficked, and high availabilities type of site, and some of the things that happen when you host systems like that. I've worked a lot in infrastructure roles and bounced back and forth between Windows and Unix. And finally, I went over completely to security in about 2006. So that's a little bit about me. Like I said, I come from the operator side of the house, which is one of the reasons why I actually got interested inside of into ModSecurity, because one of the frustrations I had with the logging in our environment, particularly if I was looking at, what happened. We had some kind of incident that occurred. Were systems attacked? What, how successful were they? I didn't have very much logging available to me. And so when I found out about ModSecurity and some of its enhanced logging that we have and the information we can gather through it, I started getting very interested in ModSecurity. And in this presentation, I wanted to kind of share some of the things that I've learned, I guess, in trying to appropriately deploy ModSecurity in my environments, and maybe pass some information on to you guys that would help you turn around and deploy that into your environments. So we're going to start off with some basics around ModSecurity. How does it work? What are some of the things that we're going to have to be aware of as we're setting it up in our environment? And what's some of that base information we're going to need to know to make sense of the data that's being presented back to us? We'll take a look at the logging capabilities, talk about how we get things ready to go into our environment, and then some different strategies for customizing ModSecurity inside of our environments and looking at the data that we're getting back out of it. So when I first learned about ModSecurity, I was working actually in a Windows shop. It was a .NET web environment, and I was actually a little bummed because I found out about this. I thought, oh, this is awesome. I could deploy this on my systems and start getting all this additional information about what's going on. And then I found out at the time that ModSecurity was Apache only, which was a little bit disappointing to me. Fortunately, that's changed now over time. Microsoft has worked with the ModSecurity project, and they've actually released a module now to deploy inside of our IIS systems, so that we can now get this type of capability inside of our Windows environments, something traditionally we only had in Apache and also Nginx. The idea behind ModSecurity is it's a web application firewall-like module that sits inside of our web servers. And it provides us with the ability to do some blocking if we configure it to do so, or just log what's happening inside of with the different activity that's occurring. So think of it in those terms as a web app firewall, but in this case it's something we're going to install inside of the web server on each of our systems, and not like an appliance sitting out there on the network. It has two modes of dealing with scoring, I guess you would call it, activity and requests from different users. The first is what they call traditional analysis, which is kind of what you would think of like a firewall. It's reading through the list of rules, and when it matches one, it takes first it takes action on it based on that first rule that it hits. And then we also have this concept of anomaly scoring. And we'll take a look at what that means a bit more later as we go. One of the really cool things about ModSecurity is that we can inspect both the requests and the responses back from the server, and we can log that information. So one of the things that always just drove me nuts, whichever you want to put this as, was I would get an alert that would say, hey, something happened. Some piece of software complained and said an event occurred. Let's say it was my IDS. Somebody made a request for an Etsy password. And that's typically all the information I would get, was that this request occurred. Very frustrating to me to do analysis on. I would get asked questions by managers. Okay, so what happened? What were the different events that led up to this? And how successful were, let's say, an attacker trying to get into the system? Or, what data was passed back? And with traditional Apache or IIS logging, you get a single line showing the request that was made, some information about the source IP, the amount of data that was transmitted, what they requested, what page they requested, and some information about their user agent and the like. Not much to go on beyond that, though. And if they were doing an attack, the only way I would ever see what that attack was is if they made a GET request, so that all the parameters were logged inside of the Apache logs. If they did it via post, then I couldn't see anything. So to me, this is an incredibly powerful bit of functionality that we have inside of ModSecurity. Really helps with the analysis, because now as I'm doing my my troubleshooting and response to some event, I can actually look through and see that, okay, here's what happened, here were the requests that were made, and I can see what information was sent back from the server to whoever requested that. So it allows me to start answering those questions much greater detail. There are a couple of sources we have to get rules for ModSecurity. The one that I use is the OWASP ModSecurity Core Rule Set. This is an OWASP project that's run by Ryan Barnett and very actively updated. For free, we can download these rules, deploy them into our environment. These aren't meant to be perfect 100% rules for every environment, but what they are meant to do is provide a lot of broad protection that they can get as much overlap as possible with all of our different environments. We can also go out and get commercial rules from TrustWave, which I've not used myself, but they have that capability. You have that option there, along with support and whatnot that I assume that comes with that. So one of the things you'll notice as you look at ModSecurity rules right away, at least that stood out to me, is one, there's a lot there to read through. And second was that I would see constant references to phase 1 or phase 2. And at first I was very confused. What on earth does that mean? And what it boils down to is that ModSecurity has different phases of its processing, where it's looking at different portions of data and performing different types of analysis. So phase 1, when you see that inside of our configuration files and inside of our rules, what we're talking about there is a user has sent a request to our web server, and ModSecurity catches that as it comes through our web server and looks at first the request headers. What's being sent inside the headers? Is somebody messing around with cookie values? We've run into instances when we're doing testing where websites are vulnerable to things like cross-site scripting through the user agent and refer fields inside of the request headers. So allows us to perform analysis based on what's happening in those HTTP headers. From there, we move into phase 2, and this is where we get into the request body. Now, like I said, with our Apache logs, we were able to see what somebody sent if they made a GET request, but that would be it. With ModSecurity, we can see that now really in any type of request that's coming across. So when it is all that data that the user or attacker is sending to our system through the as part of the request body is what we're taking a look at here. So if we're doing a post request against some form field, this is where we're going to log all of that data. And for me, this is one thing that was extremely valuable right away. Okay, most of the forms inside of my web application are posts. I'm never going to see this data. I'm never going to see what users are really doing with it, and am I really under attack or not? And because my environment ran everything over SSL, my IDS couldn't see it either. With ModSecurity sitting here inside of our web app, or excuse me, our web server, we're able to see that information. So the request comes in, it's decrypted, and now we're processing the data, and ModSecurity has full access to that. Once ModSecurity finishes doing its analysis on the request body, our web server starts to send back the data to the user, and now we move into phase 3. ModSecurity is now looking at the request headers. What header information are we sending back to the user? Phase 4 is when we get into the body of the data that is sent back. So in my earlier example, I made a comment about somebody making a request for Etsy password. Did it work? I don't know. Well, now I can tell because I can look at the data that's returned in the response body back to the user and see, oh, yep, there was my password file, or no, that attack failed. And then the last phase that we deal with inside of ModSecurity is phase 5, and this is really all of our cleanup type of stuff. There's not going to be any more ability to block or respond to traffic. We're just now logging things to disk for later analysis. So I have a URL here on the bottom of this page that allow you to go back and pull this, but this essentially came from the ModSecurity wiki that goes through this process of the different phases of processing. Now, I've mentioned the ModSecurity CRS rule set. Here's an example of one of the rules from that rule set. And as we start reading through, we can start to see what's being defined here. So we've got the response body is what we're doing our analysis on. We're looking for this string here coming back from our web server to the user. In this case, we've got a site error. An error was encountered while publishing this resource. Go down a little bit further, we can see that this is in phase 4. So again, we know that we're processing the response bodies. The block message, if we had ModSecurity configured to block, will make a comment about ZOP information leakage. So this is a rule specifically for the ZOP framework. We have an ID assigned to the rule, and then a number of different tags. Now, I really like the tags for a couple of different reasons. Well, primarily, one, if I'm customizing my own rules and creating my own things that work for my environment, I can actually put in my own tags here and make notes on what's happening here and why this is important, stuff I can search on, and even like I said, with all of these other rules from the CRS project, I'm able to build into my monitoring to look for different types of tags that are of interest to me. If PCI was an issue, maybe this is something that I would want to look at here. PCI 6.5.6 is the requirement that relates to this particular response. And then we've got some other options in here to handle things like what was our anomaly score at this point, and other environment information. Now, these rules can get really pretty busy, but generally they follow, they has all of these different points of data in it. So if you start breaking it down, it starts becoming understandable as to what's happening. And the ModSecurity project has a lot of great information on their wiki about the different options that are available. So um, it actually does, they have a lot of really good information available to us to allow us to dig into these rules and see exactly what a rule is doing and how it's configured to respond or to this particular matching event. So I mentioned that we have traditional versus anomaly processing. Out of the box, ModSecurity is going to come back with is configured for traditional response. The idea is we get a request, it's looking at the information, it matches something, and ModSecurity takes action based on that way that rule is set up right then. The advantages are that this is really easy for us to understand. I can see where an event got matched to a rule and start deciding whether or not that rule works for my environment. Do I need to make any customizations to it or have different responses than are configured by default, or is this appropriate? The downside to this is we don't get any sharing of information between the different rules. This is a very rigid kind of a response. As soon as we have a match, we're going to, let's say, block. And in this case, well, you can see here in this the option sec default action. It's phase 2, deny, and then log. So as soon as we have analyzed the headers and the request body, if we've got matches, then we're going to block that. And this sec default action is actually where we're going to define whether or not we're using traditional versus anomaly processing. And this threw me off a little bit at first when I started looking at the two, because I was looking for some kind of configuration option that would just trigger, one versus the other, that clearly related to the different processing modes. And that actually isn't how this works. We have to configure sec default action for that to fire. Down below here, you can see we've got the option for anomaly processing. Instead of saying deny, we've changed that to pass. And now we have essentially kicked ModSecurity into that anomaly processing mode. And what happens is a request comes in, we get a rule match, but instead of taking some action immediately, we increase an anomaly score. There's a value that's set to each of these requests in memory in ModSecurity, and it ratchets up this score. And finally, if it exceeds some threshold, which we can configure for our environment, then the action kicks in. Allows us to be more flexible here. We may decide that, hey, I'm not too worried about. One thing that I ran into a lot is a request header. An HTTP request header isn't set the way the rules expected. Therefore, we're going to bump this rule, or excuse me, this anomaly score up. And I can let that pass and keep processing on to other rules. And if I find other things that are occurring that shouldn't be, then I can increase that score again. Finally, once I cross my threshold, I can let ModSecurity take action on that. And one thing that you're going to find is that different applications and in your environment may have different thresholds that you set for them. Some things may be more concerned, some systems are more sensitive and more need to be monitored more closely and protected better. So you may adjust that inside of your environment. It's something that there's not really a hard and fast rule, hey, you need to set the anomaly score threshold to 10 and leave it at that. You may bump that up or down depending on what's going on. But it allows us that flexibility to respond back more appropriately to for our environments. Obviously, though, there's a little bit of a trade-off. We're going to spend some time here doing more research into what's happening and analysis on how things are being processed and responded to. A lot easier to understand, hey, we had one match and then we blocked. There are also different audit logging formats that we have to deal with. Most of the time, you're going to see this done in serial format, which is essentially one big log file with all of the data dumped into it. One of the things that the ModSecurity project calls out is that there's maybe some performance issues here with running everything in serial mode. Now, in the environments that I deployed ModSecurity into, I didn't have that particular issue. I was able to run everything in serial mode without harming the user experience because I was loading up the server with some additional overhead in the logging. But your environment may be different. If you do find that that is pushing you beyond some performance limitation you have for your environment, you may want to consider taking a look at concurrent logging. This is going to be a little bit more difficult to process. Instead of having one big log file with all of your data in it, like you would have with your Apache logs, it's going to break up the events into subdirectories and then log out different types of events related to, or portions of data related to a request and response to different files inside of that folder. So we're going to have to deal with processing a lot of different files with directories that are going to be named to an identifier, a hexadecimal identifier that we're not going to be necessarily controlling. So we need to have some monitoring here that can handle that. Like I said, I tend to use serial, and then if I found that, hey, this was just causing too much of a hit to the system, then I would look at concurrent. But for the most part, I've not found that was an issue for me. When we look at the actual logs themselves, you're going to see that these log files are very verbose. A lot of times you look at an Apache log or an IS log, it's just line separated. Here was the event, and each line is a new event or transaction or request. Not so with ModSecurity. It breaks it up into different blocks of text. And they have different separators that are present inside of this information, or excuse me, inside of our log files. And essentially what you'll see is a couple of dashes, then a unique hexadecimal identifier for it, another dash, and then the section ID, and then wraps up with a couple more dashes. And that's this example here, dash 7D 23467 4671 H, which looks really uninformative to us at first glance. But as we start looking at some information about how the log sections are defined, it starts making more sense to us. So my previous example here, I've got section H being logged for this particular block of text. Well, if I go back to my log section definitions, section H is my audit log trailer. This is information about the rule. This is where tag data is set to the event so that I can search on that later. So this is something that you'll want to kind of keep at hand as you're doing your analysis until you get familiar with the data we're looking at. So we start off first with section A. A is our audit log header, and this is something you probably won't use too much. It'll have a date, time, some IPs that are involved with it, and that's about it. And it's just one line there. Then we have our request headers. Now this is where we're going to log the information. Here's everything that the user sent to us in their HTTP request header. If they did any messing around with that, we'll see that data here. We have the request body in section C. So our post parameters are going to get logged inside of this section. Section E is our what they call the intermediary response body. Really what we need to know, this is the HTML, the content that's being pushed back to the user. This is where I'm going to see whether or not that attack was successful. Let's say a SQL injection attack was fired. did data get transferred back to the attacker or not? Allows me to answer that question that I'm going to get from my manager. Did it work? And this section will let me know whether or not it did. F is our response headers. Every time we make a request, we're going to have headers sent back, a response back from the web server to the user. There are going to be a load of header information that's sent back with this data. We've already talked about section H, basically the metadata about this type of event. J you may see from time to time. Depends on your app. If it doesn't deal with uploaded files, you won't see anything about section J. But if you do, this could be really useful. Is somebody uploading, let's say, malicious content to our server? And if so, what is that? So if I was potentially monitoring for things inside of my environment, I might monitor for section J particularly. Anytime I see this section of text pop up, I need to look at that and see where this is occurring inside the site and what kind of content is coming up to my system. Some apps depend on a file uploads quite a bit, others don't. Section K will be really useful to us when we deal with anomaly scoring. Not as big an issue with traditional. That's because what's going to happen here is we're going to get information from ModSecurity saying, hey, here was this transaction or request and data that went back to the user, and here is every single rule in order that it matched. And that allows me to chain things together and see, okay, where, here's how ModSecurity decided to take this action on that. And from there, maybe I need to mess with my anomaly thresholds, bump it up or down a little bit. I have to figure that out. Section Z really isn't a section. It's just going to be a line there to signify, hey, this transaction's over. Users made the request, we've sent their data, and we've cleaned up, we're done. So in my logs, this would just kind of be my identifier. Hey, I'm moving on to the next event. And this is an example of what a log event looks like. Again, here we have our identifier and section A. And like I said, not a whole lot of information. We've got our source IPs, ports, date and time. Section B, things start to get interesting here for us. We see that this is a post request. Now, this is an attack that I ran against DVWA, or Damn Vulnerable Web App, to generate some of this information for this presentation. And so here we can see everything that the user sent up to the web server, or the attacker rather, inside of the HTTP header. I can see where it came from, user agent. This might be interesting depending on what script is maybe harvesting against my site or running against it, maybe not. What cookie values were sent to the application. Anything like that we're interested in the HTTP header. And then section C, this is the actual attack. And this is a URL encoded bit of data, but you can see here that we've got a command being injected for cat, etc password, and then a submit. And if we followed along through here, it ran out of space. DVWA was absolutely vulnerable for this command execution page, and it returned back the HTTP password file, the etc password file to me. One of the things, though, we need to deal with when we're looking at all of this awesome data that's being logged for us, maybe there's data that we don't want to get logged. Our app requires authentication. I probably don't want to log all of their passwords, as we have username and password equal, for the parameters in our post requests. So I'm going to want to do some sanitization on that. ModSecurity provides that flexibility to us. The data that you're concerned about is going to vary based on your environment. So, for example, I worked at a company that did fraud detection in mortgage applications. So we dealt with a ton of financial information. Pieces of that information were very sensitive and things I absolutely never wanted to see inside of a log file, such as social security numbers, addresses potentially that were associated with individuals. I didn't want my log files to become a source of identifying somebody clearly. Now I want to be a little bit selective about this because I do want to see if different parameters are being attacked, but we're going to have to walk a little bit of a line here. This unfortunately is one of those areas where we're not going to have a real clear, here's how you should set this up. This is going to vary a little bit. But we want to do this customization and implement this sanitization. And where we want to set this up is, they've got some examples inside of the CRS optional rules. There will be a file labeled that when we deploy the CRS rule set. So we want to take a look at those, and we can take those as the starting place to customize them for our environment. I don't know about you guys, I'm not good at looking at the documentation and spec on how a rule should be defined and then writing that from scratch. I do much better pulling out an example, looking at it, comparing it to the spec, and then making changes where I need to from there. How we go about implementing that is going to vary depending on what or how flexible we need to be in detecting this information. The first configuration directive that ModSecurity gives us inside of our for our rules is this parameter called sanitize arg. And basically what this means is anytime you see a data parameter that's named this, like password, sanitize it, don't log it. We don't want to see that. So there are certain parameters we know every time in our app are going to contain sensitive information. So let's sanitize that and not log that information at all. We have sanitize request header. So we may have information in our request headers that are important to us, such as you get into a situation where you have an app that requires HTTP basic authentication. Which from looking at that information, when I type in my username and password, the two are my username and my password are concatenated together with a colon in between the two, and then base 64 encoded, and then sent in the HTTP header to my server. Because it's just base 64 encoded, if I'm logging that information and somebody gets access to it, it's trivial to reverse it back to the original username and passwords. So I would want to make sure I'm not logging that. And then the last option we have here is the sanitized match. In this case, this allows us to get flexible and tricky and clever and really customize this to what we want inside of our environment. We're going to be dealing with regular expressions here because ModSecurity, of course, doesn't know what all of the different parameters are, and it has to have something or other to tell it, hey, here's what you're looking at matching on. But the nice thing is all of this logging is occurring inside of phase 5, which you'll remember is just the cleanup section. So we're not going to actually interfere with the request if we make a mistake on our regex. So we're going back and we're doing our search. We've implemented our sanitization filters. And then in our tuning process, we turn around and we go back and we look at the application's activity and what data is being logged. And we can start to see, okay, that regex didn't work. It's masking too much or it's masking too little. Let me adjust that. But one of the things that we see all the time when we're doing our testing, every app is so different from company to company, particularly when you get into these custom written applications, that we need to have something to customize as well to defend our applications and monitor what's happening and appropriately keep data out of our log files. Last thing I want to do is have my ModSecurity logs become in scope for PCI because they're logging cardholder data. So that's a lot of information about how ModSecurity works, kind of the foundation here on that we have to build on for the rest of this. And I know that that's a lot to kind of process, but there's great, all of this information was pulled off of publicly available resources to us. The ModSecurity Wiki is fantastic. The OWASP ModSecurity CRS project has also a ton of information there about how we set up these rules and do our customization. So let's take a look now at what are we going to do. We've decided, okay, we want to deploy this inside of our environment. We want to start gathering up this information. What do we need to do first, and how do we get going? And I always tell people, start doing, first off, always do good web server and application hardening as much as you can. Sometimes it gets a little disheartening when we're doing some of our tests and we find that systems are just set up improperly. And as we're doing a penetration test, and all of a sudden I find myself getting access to all kinds of data because sysadmin 101 wasn't followed, and we've got a badly set up system. Once we get all that done, now we can start taking a look at ModSecurity. And as you've kind of seen already, and I'm sure thought to yourself already, we're going to need to spend some time on this. This isn't going to be something that we're going to deploy and roll out the CRS rules en masse and just turn loose on our applications. So if I was deploying this inside of my organization, one of the first things I'd look at is, okay, do I have a QA environment? Let me start off there. Get ModSecurity set up. Turn on the CRS rules. Then configure ModSecurity to do detection only. So I would want to make sure that what's going to happen is that ModSecurity is going to go into this mode where it's not actually going to block anything, but it'll let me know if it would have blocked it. And so then I can move into the tuning from there. I want to start testing the application, both as a good user and as an attacker. One of the things that always gets unnerving to me as a sysadmin when I was working is whatever we did, we needed to make sure that we weren't interfering with the valid function of the site, that we weren't blocking our customers from getting access to data, performing transactions that the application was designed to do. And sometimes these rules will get in the way of that. So we need to be prepared for that and look for those false positives. Like I said, the CRS rules are very broadly written. They're meant to match as much as they can across, who knows what for the application that it's protecting, and how that app is going to behave. So they've configured it purposely to catch a lot of stuff. They've cast a wide net. So we're going to have to watch for that. So test it out as a good user. Make sure that the application is functioning and that we're not seeing that a bunch of actions would have been blocked. I was going to run this report over here, but due to these 3 rules, I need to tweak or disable these rules so that they don't fire and block this important reporting functionality inside of the app. Want to make sure where things are happening inside of the processing mode. Is this going to be strictly traditional? One match, one block, or whatever the response is, or is this going to be in processing mode, or excuse me, anomaly mode, where we're going to have multiple rules that will combine together to cause the block? Regardless, we're going to spend a lot of time here in this tuning, just kind of going back and forth. Test, check logs, reconfigure a little bit, and then test again until we get things to a state that we're pretty happy with. We'll also find that we're going to have to deploy some custom rules. Data desanitization is probably going to be one we're going to have to visit. Make sure that we're properly masking data. We may have something that, hey, if this happened inside of my app, we have this known vulnerability because Secure Ideas came in, did a penetration test, and sent us back this information. And Dev is saying it's going to take 6 months to roll out a fix for this. Let me see if I can create some custom rules to get me over the hump in the meantime. Once we get all of that worked out, Then we can start looking at, okay, we think we've got this properly configured and everything's set up the way we want. Now let's go ahead and move into blocking mode and turn that protection on. We want to make sure we're really confident in it. Again, go back and test again, make sure the app is functioning as expected. Once everything's working in QA, then we start looking at prod. And once we start getting this rolled out and pretty well tuned for our environment, then we can start to get a bit more clever with how we deploy ModSecurity. Start implementing what I called honey traps, things to entice a bad guy to go after some resource that may or may not exist, and get them to cause themselves to stand out from the legitimate users in some way. I even read about one set of folks who went as far as setting up a beef server, and if they would implement basically, because ModSecurity can monitor and modify content as it's coming in and out of the web application, they would inject, some kind of flag to get an attacker to go after. And if somebody interacted with that, they would deploy a beef hook back to the attacker and attempt to hook their browser so they could track these guys and what they were doing. I probably wouldn't go that far, because at this point I am taking some action against the user itself, but that may be appropriate for your environment or your organization, if you're authorized to do so. But we're starting to now push some stuff out to the client, and so we want to be a little bit wary of that. But I thought it was a really clever way of follow and keep an eye on what an attacker was doing on a system. So I said, the idea of deploying these honey traps out here, this is where we're moving to a little bit more of an active defense within our application. And I don't mean active defense as in I'm going to turn around and hack back at them, but I am going to try and, like I said, entice them to make themselves stand out. So some things we can do. HTML comments. When we're performing penetration tests, we're constantly reading through all of the HTML that's coming back to us. And if we see a comment that might be interesting, then we're going to go check that out. In this case, here's this example of, we actually found this inside of a web application we were testing, where a comment says, hey, shorten to this URI, and that'll give you the error message. So if I have ModSecurity inject that into it, a legitimate user will never see it. Nothing's going to request, look at that data and then make a request on it, except for a bad guy who's checking us out actively. So as soon as I see an event like that fired, now all of a sudden they stand out from the normal crowd. Same thing, robots.txt, toss little bogus values in there, and if I see a response back, hey, let's go take a look at this. Hidden parameters inside of forms. We can actually have ModSecurity modify different forms and inject a bogus parameter, or even cookies that aren't real. Regardless, like I said, the idea is to just kind of provide some interesting or tasty little targets for an attacker to go after and want to take a look at. And then when they do, we can take a closer look at them and have our monitoring systems, take action on that, fire off alerts to systems administrators and security engineers. Hey, we've got somebody who's really checking us out. Now, all of this is going to be done within custom rules. And like I've said before, every web app is different. We're going to have different reasons for doing these rules, so we may have to roll our own a little bit or modify our rules to work within our environment. We may need to deal with patches to hold off attackers while dev is working on a final fix for a vulnerability that we know about. The key thing that we need to keep in mind here is that we don't want to mix our custom rules with the distributed rules. And what I mean by that is when we get updates from the CRS project, we don't want to have a bunch of customization written into those individual into those files, because the next time we do an update, we're going to overwrite them. So we need to have our own rule file set up. And the way that we can do that is by going in here to our web server, and let's see, we got, yeah, here we go. So inside on my demo web server here, I've got this directory called Etsy ModSecurity Activated Rules, and inside of that that directory, I've set up my own custom rule file here. If I take a look at that, we can see what it was I was up to. And in this case, this was an example of a honey trap. If I saw a request for admin.php, then, hey, this is somebody who's checking me out. This request is going to show up in phase 1 or phase 2. And the different tags that I've set up here, when I've got my message, that I customized here, request indicates someone's scoping out the application, and my tag for that this is potentially reconnaissance. Somebody's taking a look at my app. So this is an example of a custom rule that I rolled out. And when I update the CRS rules, which are all of these other ModSecurity CRS labeled files, I'm not going to get my own rules overwritten at this point. I keep my customizations. So that is something you want to be aware of as you're managing your environment. Make sure that you're not modifying those source files, because otherwise next update you're going to lose all the work you've put into that. Here's another custom rule. This was actually from Shark, which is an HTML5 project that Secure Ideas did. In this case, looking for somebody attempting to overwrite browser history and send that back to the client's browser. All right. One of the things I'm sure you guys, we've collected all this data now. It's time to do analysis, and I'm sure you all have looked at Apache logs, or really any log file written by applications inside of your environment, and seen that even on just line separated logged events, it's an overwhelming amount of data to deal with. So ModSecurity almost makes it worse in some ways, because instead of single lines, we're looking at blocks of text and different sections that relate to each other. So we're going to need to make sure that we have some tools to help us out with our analysis. And there are a number of different options out there. Some you may be able to leverage inside of your environments already with tools you have in place. Others you may need to deploy. The thing that I like to comment on first, though, is take a look and try and figure out ahead of time what it is that we're going to want to do our analysis on. So, for example, I would be interested, after I finish all of my tuning and I've gotten rid of the noise and the false positives, I would be really interested in any alerts, of course, that are firing for SQL injection, cross-site scripting, any of those major vulnerability categories that we worry about inside of our apps. And I would just want to monitor that activity over time and maybe trend that out, and then dive into those individual alerts or series of alerts and see what's going on. Again, this becomes more useful to us after we finish with our tuning. Obviously, if we're implementing the honey traps where we've got false flags laid down, any interaction with those is something we want to look at, because the idea is to set it up so that a regular user or system that is, let's say, interacting with our web server wouldn't request that resource or make that type of request. So anytime we see something that trips one of those flags, we want to look at it. This looks like somebody is actually really poking at us and doing something. And then other things that I would look at are changes to the environment, changes in volume. different types of activities that are occurring inside of the application, activity that's occurring in time windows that shouldn't be or are abnormal. There's all kind of normal stuff that we just need, even some things that we could see with our Apache logs, but plays into our analysis here with ModSecurity. And obviously, if I do see something that I'm looking at, it looks like I've got a potential attack and maybe it was successful, what did the attacker send and what did they get back? And a note on when we do our analysis, I was talking to somebody a few months ago, one of our clients, and we were discussing log analysis. And he made the comment, he said, hey, I've got tons of stuff I'm supposed to be doing. I've got all of these projects I'm working on here. I've got my maintenance that I'm normally trying to deal with. I've got people walking by my desk all the time asking me to go do something for them. And I understand that because that's the world I came from too, where that was a normal day. And the idea of adding in log analysis and trying to figure out, hey, how do I even know when things have changed inside of my environment was a little overwhelming. And my advice to him was something that I had found out myself. Was that even a little bit of time on a regular basis starts to get you really familiar with what's going on in your environment, and you get a feel for what's normal. And so it allows you to start to spot when something's abnormal. And really, if you spend an hour a day or half hour a day or whatever it is you can grab, but on that regular basis, looking through log files, you start to figure out, hey, this is what's normal for my environment, and here's what's not. And if it's not, that's something I want to check out. The first tool I'm going to mention here is the free tool written specifically for ModSecurity. It's called the Audit Console. It's a Java application, so it's going to take a little bit of work to get it set up, particularly since one of the things that we do to collect or put the data into it is we create a sensor which listens on the network, creates an RPC interface, and then we configure mlogc in Apache, for example, to send that data to that RPC interface. And I've had a little bit of varied success here with getting this mechanism working properly. But the nice thing here is we're looking at an application that was written with ModSecurity in mind and has a lot of stuff built in, ready to go for us. And here's what that looks like. It's a web interface, runs SSL out of the box, by default with a self-signed cert. But we can start to see trends over time. We've got some histograms here to tell us, hey, here are the alerts and the volume that we're receiving over time. Now, obviously, this looks like a rather short period of time that this is focusing on, the last hour. But if I saw something suddenly spike, where here's my login activity normally over the week, and then all of a sudden we have a large spike in activity, what's going on here? Do I have a brute force attack occurring? Do I have somebody that's a parameter, let's say, in a page a page that gets requested a lot, and all of a sudden I have a spike in alerts for that page? Maybe. From there, we can dive down. If we select an individual alert, we can dive down into the details of it. And here we can see the items where we had a map on the on the options, in the HTTP options. So this rule started firing. It looks like this was set up for anomaly mode because the next item here is saying that this is greater than the anomaly score that was set for this. And then down below we have the actual data that was the rule rather that was used to match this. From there we can move into an app. This is what I tend to use because I came in environments that use Splunk already for normal operations, and I hesitated to put this in here, but at first when I was planning this out, but a lot of environments have it that I run across. So if you have this already deployed, it's something to look at. The nice thing about Splunk is it's really flexible. We take text, we shove it into it, and it becomes searchable. The problem is, of course, is that it's not written for ModSecurity, so we're going to have to do a lot of customization on that. So what I've got here below is the regex actually to match the different boundaries. This is what we're going to have to send to Splunk when we define this source type or the type of data that we're dealing with. And it's going to look for that hexadecimal identifier along with a single boundary or section of text, right? The letter indicator for what data it is that we're looking at. The nice thing is we get that customized and set up. We can shove it in here, and now we can start building our own queries and even applications inside of Splunk to deal with that. So I'm going to take a quick look at that. I know we're really running out of time, but I want to just bring up this was a quick and dirty Splunk app that I created for ModSecurity. Nothing fancy, and this isn't something that I would say is probably production ready to deploy, but it worked okay. We have our different types of injection attacks that are going on here. SQL injection, file injection. We've got some events where my honey trap has been triggered, cross-site scripting. I can dig down into the details of those. Like I said before, any interaction with a honey trap is going to be of interest to me, so I would select on that. And here are all of these different requests for admin.php. And I'm pulling this out of the audit log information. So it's section H. So, but what I'm searching for here really is this tag for this query. So if I was doing my analysis on this, I could dig in and look at the full body here of this section. And if I'm interested in this, I want to see, okay, well, what's going on here with this particular event? Click on that. Now I'm still only getting section H because of this. It's the only field that's going to contain this tag. So if I remove that, now I get the full request and response back from the attacker to the system and back again to the attacker. We have our opening request here, or excuse me, the start of our transaction. Section B is going to be where we're dealing with the HTTP headers. Here's where we've got that GET request for admin.php, which didn't exist in this application. That was something that I faked up with robots.txt, and an attacker went and looked at it. Then, oops. Let me go back. Sorry about that. Clicked on the wrong thing. This is our response from the system back to the user. And for whatever reason, I'm not getting my content in here. But this is where you would see things like, in this case, a 404 error going back to the end user. So John put out a link here to an app for a Splunk app that exists for ModSecurity. And John, you're right, that is there, and that is one that I looked at. There are a couple issues I had with that particular app. One, there was a ton of different other Splunk applications that needed to be installed for it to work, prerequisites, and things like Google Maps and some other library or graphical oriented apps to format data. And some of those apps had changed where they were a little bit more commercial in nature. So anyhow, it's something that I ended up getting away from because of that. But if you want to use that as a starting place, it's something I set up and worked around with a little bit. And if it works for your environment, that's fantastic. Some of the resources that we have out here for ModSecurity. These are areas that I went to for, as I was going through my experience with it, with this application. One is just the reference manual and the data formats, the things that are provided from the ModSecurity project. ModSecurity heavily sponsored by Trustwave Spider Labs. So they host a lot of this information. The reference manual is an excellent source of information to help you out as you're going through your configuration. The data formats are going to be important as you're looking at all of this data and understanding what it is you're trying to do your analysis on. Some presentations that I liked. Ryan Barnett, I mentioned earlier, he's the project lead for the OWASP Mod CRS project, Mod Security CRS project, and he's got a number of excellent presentations up on Vimeo. You can go check that out. And then a couple of books. There's the Mod Security Handbook. Was written by Ivan Ristic, the original author of Mod Security, and then the Web Application Defenders Cookbook, which came from Ryan Barnett as well. All of those are out there for you. And I'm going to do a blog post on this later. I think I'm going to put these slides up on our blog so that you guys can download them and take a look at that and get access to these URLs and links that are part of this presentation. And with that, we've reached our 2 o'clock hour here. It's time to wrap it up. Did anybody have any questions or anything like that they wanted to ask before we close up? Got a minute or two for that, and you can just type those into the to the chat function inside of GoToTraining. I got a comment saying that they'd like to listen to this again. I believe this is being recorded, so you're going to need to. So we'll hopefully get that out and published later. Question: what's the impact of CPU on enabling mod security? A couple of questions about CPU requirements. So that's really going to vary. And the reason why I say that, you're absolutely going to see overhead for all of this additional processing. There's going to be additional memory requirements. And I've seen systems where this becomes a bit more of a problem. For example, one system that I've managed has probably about 80 different websites, PHP websites running on it, that are all getting hit at once. And the CPU hit for mod security at that point was definitely something I had to keep an eye on. You will probably find, though, that depending on your application, that may or may not be a big issue. A lot of the apps that I worked on the web server where this analysis would be taking place wasn't doing a lot of application logic. The databases were off on other systems. There was an app server or application tier that handled a lot of our logic. So the CPU on our web servers was really pretty mellow. So a hit of a few percent wasn't a big deal. Again, this is why I would recommend deploying this out in QA first and doing some testing there. Is it a good idea to install mod security on a reverse proxy hosting 100 sites or more per site or per system? So yeah, you could totally do that. I talked to one gentleman who was doing that type of monitoring, and he was asking me about setting up a reverse proxy just for that. I had considered deploying mod security as a proxy system from when prior to the version being ready to go for IAS. As far as it being a good idea, I don't see anything wrong with it. Essentially what we're doing is we're stepping out and making mod security an appliance, like a typical web app firewall would be. Some things that we would have to consider, though, if we're using SSL to perform our encryption and whatnot, we would need to make sure, of course, that we were able to properly terminate that SSL at the proxy, and then back from there to the web servers, so we get value out of the inspection of all of this data. So it's just something from the systems administration side of things we're going to have to deal with. But I think it's fine. You would just need to make sure that it's able to handle that type of load as you're dealing with 100 plus sites or better. All right. If y'all have any other questions, my contact information is here up on the screen. Please feel free to drop me an email. I really appreciate you guys spending an hour here listening to this presentation. I hope it was useful and is something you guys can take back to use in your own environments. Like I said, we covered a lot of ground here. Mod security is a bit of a complicated beast, um, but it's just a fantastic source of information as we're monitoring our environments, we're responding to events, and trying to deploy some protections out there.